So the first thing is, why is this important? And especially, why is probability important? Statistics tests are used to determine the probability the groups are different, or if you're doing correlation, if they're related. And what we're looking at is the difference between two groups, is that purely due to chance or probability? Okay, what we're not dealing with in statistics is certainty. We're never proving anything. We don't know for sure. What we're looking at is we're testing a hypothesis. We start with a null, that there's no difference. And then we test the alternative, and then we will either reject or fail to reject that null hypothesis. So the probability testing is used to determine if there is a statistically significant difference or relationship, depending on the type of test you do. So it's based on another term thrown out there, is the risk of a type 1 error, or the alpha. Okay, those all kind of blend together, kind of all really talking about the same thing. And I'll get a little bit more detailed on that in a moment. So what do you need to do to know as far as probability? Well, first of all, just kind of the basis for understanding probability. Now that we have computers, you don't really have to be able to perform the calculations. That's what computers are for. What you need to do is understand and interpret the probability and how it applies to statistics. Another thing that's really helpful and confusing to students is, how is probability noted in statistics? And I'll just tackle that right now. One way is with what we call the p-value. And think of p as standing for probability. So a lot of times you'll see a p is less than 0.05. Okay, so that means the p-value was less than 5%. There was less than a 5% chance that the difference could be just due to normal variation. SPSS tries to make things a little bit difficult because they never use the term probability. They don't say p-value. When you see the word SIG with a period, that means significance. But in SPSS words, it's the same thing. It means the probability. So you might have a SIG of 0.035. That's the same thing. It means the probability was 3.5%, for example. I won't ask the question, but many of you, I'm sure, use Excel. If you run Excel, if you run stat functions in Excel, if you run, say, a t-test, the output, it doesn't even label it. It just gives you an equal sign and then a number. That number is the p-value, or the probability. So there's different ways to note what it is. It's the decision rule. And for most of us in research, we're setting our decision rule at either 0.05 or 0.01. So an example, p less than 0.05. That means the probability, if the probability is less than 5%, we're going to reject the null hypothesis. Well, what does probability mean in the first place? How many of you play games of chance? Again, just put in the chat, if you play cards, play poker or blackjack, roll dice. If you play any other kind of games of chance, probably over the holidays, many of you, New Year's Eve parties, you may have had playing a game of chance. I was playing backgammon with my wife over the holidays. The first two games I won, so I was considering that a game of skill. And then the next two games she won, so then I considered it a game of chance. But in either way, many of these games are games of chance. And to be really good at a game of chance, you need to understand probability. How does that relate to statistics? Well, we use that same statistical probability, again, for either testing differences or testing relationships. Yeah, the Powerball. My goodness, what was the probability of a Powerball winner? I should have put that in this presentation. Oh my goodness.
That would have been great.
So the probability, how do you calculate the probability? It's the number of the outcome over the total number. So again, in our courses, what's the probability of passing your stats course? If there's 30 people in the course and 3 people fail, then there's a 10% chance of failing and a 90% chance of passing. If you're in public health, what is the probability of getting the flu this winter? Okay, we do stats and we can figure out the probability. There are a bunch of you that were in business. What is, if you're doing, say, inventory, what is the probability of running out of, being stocked out of an item? Or even worse, the probability of running out of cash. You literally do probability studies to figure that out. If you're in nursing or healthcare, what is the probability of having a medication reaction? And sometimes it's the risk and benefit. So you're trying to figure out both the probability of an adverse event as well as the probability of a good outcome. So again, practical terms, flipping a coin. What's the probability of, if you have a two-sided coin, if you flip a coin, what is the probability of heads? Go ahead and answer that in your chat. And I'm doing this to make sure everybody's still listening. Yep, 0.5, 50%. Good. Okay. All correct answers. What's the probability of getting heads twice in a row? I'm tricking some of you, aren't I? Let's see what this is. Okay. So if you do heads or tails twice, the first time, you really have four options. You're either going to get heads or tails on the first choice, but the second time, you're either going to get a second head, a heads and a tails and a heads, or two tails. So it's actually 25%, 1 in 4. Mathematically, it's 0.5 times 0.5. Every time, if you wanted to do heads 3 times in a row, it would be 0.5 cubed. Last example, if you're playing cards, and for those of you that don't play cards, there's 52 cards in a deck. There's 4 suits: spades, clubs, hearts, and diamonds. Spades and clubs are black, hearts and diamonds are red. What is the probability of being dealt a black card? Go ahead and type that in. 0.5, 50, that's right, half the cards are black. What is the probability of being dealt a spade? 1 in 4, 25%. Good. You're very sharp, or a lot of card players, one of the two. What is the probability of being dealt an ace? Remember there's 13 cards in each suit, so it would be 1 of 13, or 4 in 52. And what is the probability of being dealt the ace of spades? 1 in 52. Awesome. Sharp group. Make it a little tougher. What is the probability of being dealt 4 aces? Okay, you have to use a little bit more concept here. The first card, there's 4 aces, so it's 4 out of 52. The second card, remember, one of the cards is already used up, so there's only 3 aces left and only 51 cards left. So the second card, it's 3 and 51. When you're dealt the third card, there's only 2 aces left and there's only 50 cards left. And with the fourth card, there's only 1 ace left and there's 49 cards left. And to do that calculation, it's kind of like the Powerball now. Okay, so it's 4 divided by 52 times 3 divided by 51 times 2 divided by 50 times 1 divided by 49. Once you figure this math out, you'll never go to Las Vegas again. Or I saw some of you in New Jersey, you'll never go to Atlantic City.